Hello, welcome back to another episode of Coffee Cats. This is the series Introduction to Soil Testing and Soil Fertility. In this episode, we're going to be talking about soil testing and specifically analysis of those samples you can collect. So when we take and send off a soil sample for analysis, we've gone out in the field, we've collected it. If you haven't watched that video, go check it out on collecting soil samples. We're sending it off for a chemical analysis, and there are multiple soil tests out there that use different procedures and chemicals to extract nutrients. In this pie chart here, we're showing phosphorus, but it's extracting that phosphorus or that potassium from different pools that are found in the soil. And that soil extractant, each one can extract different amounts of nutrients, and they extract it from different soil pools. So this is why you get different numbers back. If you say have a Mehlich 3 soil test versus a Mehlich 1 or a modified Morgan or a Bray soil test, they're all using different chemicals, and so they're pulling out slightly different amounts of that phosphorus or potassium from those different kind of pools in the soil. In this example, we have iron-bound P, aluminum-bound P. Organic phosphorus makes up a huge chunk of the phosphorus in the soil. Phosphorus that is absorbed to the surface of the clay, or phosphorus that's in the soil solution that's dissolved in the water that's in the soil. But the point here is that with all these different soil tests, what you really need is that local correlation and calibration for that soil test to be useful. So if you're in Kentucky and you go and get a soil sample analysis from a New England state that uses the modified Morgan test, those results will be useless to you in Kentucky because you don't have correlation or calibration data that tells you how much fertilizer you need for that amount extracted by the modified Morgan. There was a study done a few years back by the northeastern states where they collected 51 different soils from across multiple states, and they used different soil tests to extract all those samples so they could compare them. And in this one, they compared that modified Morgan test used by the New England states to Mehlich 3, and we can see that you get very different numbers from the two tests. In fact, Mehlich 3 extracted anywhere from 2 times more phosphorus to 90 times more phosphorus than modified Morgan. And not only did it extract more, but the two methods are not correlated well. They had a really low R squared, meaning that sometimes when the samples were extracted with Mehlich 3, they had a lot more higher ratio phosphorus extracted than by the modified Morgan test. And so they do not predict the same fields to be responsive. So for example, in Maryland, this red line going horizontally across here would be the responsive. Anything below that we consider responsive to fertilizer. If we look at modified Morgan, many of the states that use that use a critical level of about 4. So anything to the left of that vertical red line on the modified Morgan scale, we'd expect to need fertilizer phosphorus. And you can see in this example that there's this group of samples that are above the red line at 50, but below the red line at 4 for modified Morgan. So these two tests don't even say that the same fields are in need of fertilizer. So we definitely can't go across state lines and use different soil test extractants. And that's because there's basically different chemistry in those extractants. In this example, we're just showing a water extraction versus what's called a Bray soil test and a Mehlich 3 soil test. And in this case, all three labs would be using a scoop, and so the amount of soil they take out is in cubic centimeters, but each lab would use a different size scoop and a different amount of extracting solution, whether it's 50 mils, 20 mils, or 25 mils. And then we look at the chemistries, and it's very different chemistries for these three tests, different shake times, and then they filter them. So with all these differences, it's no wonder that we don't get the same number. And so, you have these different chemical extractants from different labs and different soil methods. Sometimes also labs will report in different units. So even if you send your sample to 2 labs and they both use Mehlich 3, you may get different numbers because one, like the University of Kentucky lab, reports in pounds per acre of nutrient, and another lab might report those results in parts per million or milligrams per kilogram, where there's even labs that don't give a unit, they just give a fertility index value. And so those numbers would be very different. Also, basis of expression. For example, at University of Kentucky, our soil test report gives pounds per acre of K, not pounds per acre of K2O, that oxide equivalent. When you do a soil test, when you have a soil analysis, the soil testing should provide a measurement of the nutrients in the soil solution, so what's immediately available to the plant. We refer to that in the quantity intensity world, which we described in the previous episode. That intensity is what's available to the plant immediately in the soil solution. And then there's these different kind of stored pools, with soil minerals being the long-term storage, organic matter being a medium-term storage, and the exchangeable cations or anions on soil colloids. Those are the stored, the really immediately available. They're stored, but they're going to probably be available in this year. And so soil testing is trying to provide a measurement of that intensity and then some estimate of the quantity that will become available this year. And so that's the buffer capacity, that change in quantity with respect to quantity to the intensity. And so that's what soil testing is trying to do. But because so many factors influence the quantity intensity relationship, soil testing can only provide an index of nutrient supplying capacity of the soil. It's not an absolute number, it's just kind of an index of relative availability. And so we need to do some other work for that soil analysis to be meaningful. But we're extracting portions of the stored nutrient pools and the most labile nutrients in this kind of storage from long to short term, and trying to index what we're going to get this year. So when you select a soil test method, you've got to be aware that the extractable nutrient value has little meaning unless they've been shown to relate to that plant response to application of an element and the soil test level at which that response occurs. So that's calibration and correlation. And so this requires that research under regional conditions with representative soils ranging from deficient to adequate for a given nutrient in order to get a useful recommendation out of a soil test. So in summary, different soil test methods return different results. They each extract a defined amount of nutrient from various nutrient pools in the soil. They attempt to provide a relative index of potential nutrient availability, and the soil test method that you select is only as good as the local correlation and calibration data sets that are available.